Okay, we're gonna pick up where we left off, and um, let me move this one. There we go. Here we go. We're needing to divide complex numbers. So let's start off simple. The simple kind are the ones where you have just a monomial in the bottom, and that's it. Um, Simply speaking, in math, you're not allowed to have radicals in the bottom. So most of you know that this is not a sufficient way to list your answer, that you have to rationalize that. Um, it may not be obvious to you that whenever you have 2 over 3i, it's the same business. But if you'll remember what that is equal to, I was defined as the square root of -1. So even though you may not be seeing a square root, it really is a square root. So it falls under that same rule. You have to rationalize it. So the way we're going to do that is, since it's just a monomial, the only problem here is I. So if we will multiply top and bottom by I, now keep in mind, that is mathematically legal because anything over itself is 1. So I'm really multiplying 7 over 5i times 1, which means I'm not changing its value. I am going to change what it looks like, but the value will not change. So whenever I multiply fractions, you multiply straight across. So 7 times I, 7i, and 5i times I is 5i squared. Well, hopefully you remember what happens when you have I squared, because if you do, I squared is equal to -1. So just to refresh your memory, that means we would have that, which is 7i over -5. Now, typically you don't put the negative in the bottom. You either put it up top or right there beside the fraction bar. But normally you don't leave it in the bottom. But this is all we get. If you did the shortcut and did right here, if you said, well, we got this right here. If you were like, well, that's going to be -5, then good. You just went straight there. So just clean it up when you're done. So again, if you've got one and it's just got a monomial, multiply by the I part, and then you've got 11i over, and that's going to be 13i squared. Well, we now know that the I squared is going to make that -13. So we're going to clean it up. We're going to make that -11 over 13. Now we don't have any i's, excuse me, I forgot my I. We don't have any complex in the denominator, and it's fine. Okay, so let's kick it up a notch. This is one of the things that we need when we get into the next level. So just kind of a detour. Pause and let's think. Hopefully you recognize these. When you have the same terms but opposite signs, those things are called conjugates. And you can do conjugates with complex numbers, and you can also do conjugates with irrational numbers. That's the ones down here with the square roots. And by the way, that should have been 7. Oops. But conjugates have a wonderful, wonderful property. So let's just take the first one and just play with it for just a second. If you multiply these two things, something beautiful happens. So that gives me 2 times 2 is 4, 2 times 3i is 6i, and that's going to give me a -6i, and that's going to give me a -9i squared. Okay, if you remember our trick, that's the I squared. So what it's going to do to this term, that's going to be -9 times a -1, which gives me a +9. So it will always take this number right here and change the sign. That's what I squared does. So then we can take the 4 and the 9 and put it together. Well, when you get to this part, hopefully you have that, oh, my middle terms disappeared. That is the beauty of conjugates. The middle terms will always be exactly the same and disappear so that your answer is real. It's not complex. It is only real. And that's what we need when we dive into these. Because now we have binomials in the denominator. So multiplying by I is not going to help anything. So this is like not helpful at all. Okay, so this is wrong. If I said I over I like I did the other column, that's going to give me 3i in the top, but in the bottom I'll get 2i plus I squared. Well, I mean the I squared will fix itself. That'll become a -1, but all we did was move the I over. We didn't do anything but just move i's around. So we don't want to do that. That's a bad deal. So you got to have a different plan. So when you come in here with a different plan, it needs to be conjugates. And you want the conjugate of the denominator, because that's what you're aiming at. You really don't care what the numerator looks like. It could be the biggest, hottest mess you've ever seen. But the denominator needs to be real. So if I've got 2 plus I need 2 minus I. Oh, and I'm in that wiggle in my board. Give me just a second. Let me do this. Okay. There's something wrong with my board there, and it makes me look like I'm a 2-year-old. So we'll just scoot down. Here we go. So I've got to multiply by the conjugate. Now remember how we build this fraction. I have to multiply, make this like it's 1. Because I don't want to change the value of the first fraction. So if I put 2 minus I in the bottom, I must put 2 minus I in the top. So anything over itself is 1. All right, now I can multiply. Now if it would help you to put the parentheses so that you can remember that means distribute, then you need to wrap it up. So I'm going to do 3 times everything here. So that's going to give me 6 minus 3i. And remember, we really don't care what happens to the top. Yes, we want it right, but we don't care if it's complex, if it's real, whatever. Let the chips fall where it may. In the bottom, we're a little bit more particular. We don't need any i's. So this is going to give me 4. This is going to give me negative 2i. Then I go back and get my I. I times 2 is positive 2i. I times negative I is negative I squared. So I'm purposely doing it the long way right now. The middle terms are canceling. And if you'll remember the trick, that's a 1, by the way. What that's going to, I squared is going to change that sign. So that right there will be plus 1. So I have 6 minus 3i all over, and I've got 4 plus 1 is 5. Nothing reduces. Remember, you have to look at all 3 and see if they reduce. They do not, so that's my answer. If you're in college algebra and you're doing WebAssign will not take that answer. WebAssign is going to force you to put it in this form. The way you do that is you just bust up your fraction. So you do the 6 over the 5, and then you do this part over 5, so minus 3 over 5, and they really want you to pull the I out like that. So it's just this fraction beside times the I. So that's how WebAssign is going to want you to type that in. If either of these two reduce, yeah, go ahead and reduce them. Now, there is a shortcut, and I did just kind of fly through it there, but there's a shortcut up here where we're multiplying. The whole point of what we're doing is to make these middle terms go out. So if you are purposely doing that and you're using your conjugates, you really don't have to multiply them out because you know they're going away anyway. That's your devious little plan. Also, there's something else that's going to always happen. Your signs will always be opposite if you're using conjugates, which means that this sign will always be a negative. There's another always. It's going to be imaginary times imaginary. So this one will always be I squared, which means you will always change this sign that was negative, which, throws it into being a positive. So with that said, what you're going to end up in the bottom with is you're going to do square the first number. It will always end up a plus because you're going to have minus an I squared. And then you're going to have square the last number. And that's the way you fill in the bottom. See, I had 2, so 2 squared is 4. And then I had 1. 1 squared is 1. So it's just always going to work that way in the bottom. So if you want to do the shortcut, you can. All right, I wanted to try one that actually worked out and reduced. I think this one does. So this is one of those that you do have to rewrite. So that would be 2 minus 4i. And this is 3 plus regular I. Now, again, you got i's in the denominator. You've got to fix it. So pull out your conjugate, 3 minus I. This is a harder problem because you do have binomials in both tops and bottoms. So it just gets, it's not necessarily harder, it's just longer. There's a difference between those two things. So let's distribute the 2, and that's going to give me 6 minus 2i. Now we're going to distribute the negative 4i. So negative 12i, and negative 4i times negative I is positive 4i squared. Don't try to do too many things at once because you can get lost in the signs. Safer to go slow if you're in question. All right, now I'm going to use the trick because think about it. I'm going to have 3 times 3. That's just 3 squared. I'm going to have a positive I times a negative I. Well, that's going to be negative I squared. So I know it's going to be positive. I'm going to square that last number. I get a 1 because that's 1i. So if that weirds you out, put the 1 there. Okay, let's clean. This right here is going to become negative 4. So I'm going to put the negative 4 with 6. That gives me 2. Well, these two together are going to give me a negative 14i. And in the bottom, cleans up to a 10. Now, here we go. You are not just allowed to reduce it, you are required to reduce it. Now, if you're in WebAssign, you're going to be busting up the fraction anyway, so WebAssign, it's really not going to mess with you, because in the computer, you guys are going to be saying, okay, so 2 over 10 minus 14 over 10, and then with an I. So it's going to be obvious that this is 1/5, excuse me, and then 7/5 with an I. So that's what you're going to need to type in the computer. Thing is, that's not how we typically write it on paper for quizzes and tests and so forth and everything. Whenever you go beyond my class and you go somewhere else, they're going to expect you to write in the traditional form. Now, the way that works is you need to look at all 3 of these terms and reduce by the largest number that goes in it. Please don't try to reduce just 2 of them. Don't try to just do the 2 and the 10 or the 14 and the 10. The whole reason you can reduce is because you can factor the top. Nobody ever writes this step, but this is why it's possible. So hang on. In the top, everybody's even. You can take a 2 out. So that's 1 minus 7i. Okay, you put your denominator down there. Now, here's the rule. You can only reduce top and bottom when these are factors. You cannot reduce terms, you can only reduce factors. So here is a factor here, and here is a factor here. They're called factors because they're multiplied together. So that's what frees this 2 up, is the fact that it's multiplied times this difference. So the 2 reduces with the 10, and that's how I get 1 minus 7i over 5. Now, most of us don't ever do that. You're just going to look at this thing right here, and you're going to say, okay, I got 2, 14, and 10. The biggest number that goes into all 3 is 2. So let me divide all 3 of them by 2. 2 divided by 2 is 1, 14 divided by 2 is 7, and 10 divided by 2 is 5. And we just stop right there with the answer. But I wanted you to see why. It's not just because somebody told you to. It's the rules of algebra. You can only reduce factors, not terms. So you can do the shortcut if all 3 of them do it. But this is the why behind it all. Okay, I hope that helps you out with complex numbers. Now make sure that you practice your homework. Come with me. Come to see me if you've got some more questions.